I'm good the time of recording. Okay, yeah,
Okay.
let's start now. Okay, so this is
So,
so let us start with the architecture. You can put it on mute yourself. Yeah, thanks. Okay, so this is DataGuard architecture for Oracle. So starting from Oracle 11G. So these are the hardware and operating system. So what is DataGuard is? DataGuard is a kind of we earlier we used to call it as a standby machine. Now it is a term which has come from 11G is DataGuard, where it is a kind of a real-time replication which is going on from the primary database to the standby database, which is also known as a data guard as well. The complete structure of primary and standby are known as a data guard. Okay, so where the all the transaction which is happening in the primary is getting replicated, is getting replicated to the standby machine. Okay, so they should be always in almost in sync. Okay, and there are different tools we would be using to manage it. They should always in sync. So what are the benefits? Why we prepare a data guard is, or why we prepare a standby database is, why we go for a setup of data guard is, the primary reason is, the first and most primary reason is the failover setup. Like failover setup, yeah, I think not mentioned over in the slides. Okay, I'm just going through. So failover setup is kind of just assume if your database primary database fails, so it can quickly switch over to the standby database. So your transaction, everything can move to the standby database. So now if you assume anything happen, any crash happen on your primary database, you need to restore, recover from the backup, right? And definitely this will take time. This cannot be in few minutes. It's a huge database. You might need to troubleshoot what happened. Is a physical corruption, logical corruption, or complete control file, data file lost. Anything can happen, right? Any disk failure, anything can happen. So you can quickly switch over to the standby machine. So there can be standby which is completely in sync, or might be there is can be few seconds of lag. We will study about the different types of standby databases as well. Okay, so first then primary benefit, primary reason to set up a standby machine is the failover. Okay, secondly is the offloading server. It can also be used as an offloading server sometimes, but for that case there are exceptions. Definitely database need to be open in the read-only mode, which is not always. We'll study when we can open our database in read-only mode. That too is a very new feature in Oracle, which is known as the active data guard. Okay, so this structure of primary and standby are completely known as a data guard, and there are different tools which came up in 10G, 11G, and 12C versions, where you can do a failover, where a failover can be done automatic. Failover can be automatic means if primary gets down due to any issue, the automatically the standby becomes a primary database. Okay, and it shuts down the primary, and and until the time stand the then the primary which was just down now, which is corrupted now, till the time it is not fixed, it can still behave as a standby. So you can reverse the replication from primary to standby to primary. So we'll go through all these things in detail in this course. Okay, and moreover in this architecture, the first lesson is the architecture, how does it works. Then we are going to implement it in both the ways. Like one is the physical standby, which is more popular than is a logical standby, which has some limitations, restrictions, so which is lesser popular. We'll study both of them. Okay, so let us go through what is the requirement on the hardware and the operating system. What are the limitations on this? So hardware can be different. Okay, your hardware can be different. You can have any number of CPUs, hard disk, any Intel or any chip disk or any hardware. There is no limitation the hardware as such, but the operating system and the platform architecture must be same. So operating system releases, the versions can be different, but the operating system should be same. I cannot have a standby. I cannot have a Oracle which is hosted on Windows and a standby on a Linux machine. So it should be same. The version might be different, but it should be, the operating system should be same. Okay. So generally we have primary and standby on different machines, because that only serves the purpose of a standby, right? If the standby is in the same machine, definitely there's a risk that the if a disk failure occurs, that might be occurring on the same machine, right? So the purpose actually is not resolved. Okay, so better we have on a different machine. But in case we are hosting on the same server due to some reason, then the operating system should allow to mount the two databases the same name. That means that the primary and the standby is of the same name. The database name of the primary and standby are same. So it should allow us to host it on the same name, because generally if you see, if in the etc or a tab, the instances name definitely can be different. So we need to configure it in the same in such a way that it is still able to allow us to have the same database name. Okay, might be we keep instances name different, or maybe with a parameter which is the DB unique name. Okay, we'll work on this parameter. We generally don't use this parameter or take give attention to this parameter unless we are configuring DataGuard. Okay, but database name should be same. That is the primary requirement for the building of the standby database. So I hope this is very easy to understand, that the hardware can be different, but operating system should be same. The releases can be different. This is the primary requirement. It requires the other requirements at the Oracle database software end is it should be an enterprise edition. Standard edition doesn't have a data guard feature. Okay, it should be integrated. You need to have a sysdba privileges to configure the database, because you need to change lot of parameters. You might need to restart your databases as well. Okay, generally most of the parameters on the primary side need not to be restarted, or it might on the standby side you might need to restart it. The database should be in the archive log mode. Definitely archive log is required. Each database must have its own control file. You need to enable the forced logging mode. I think forced logging mode you must be knowing, because this is a DBA thing. So forced logging mode should be enabled on the database. This is because that it reads your archive files. Okay, now if you want their standby should always remain in sync, right? If the standby always remain in sync, you it always, then it will keep a gap. If always means, then to keep it in sync, it reads your redo log files and archive files. It reads the redo log files, and if the data is not going into redo log and archive files, it cannot be in sync. So you need to enable the force logging mode. Your database should be in the archive log mode, should enable, so that every transaction that is happening in your database goes into the redo log file. Correct. So if any database use ASM or OFO, all should use the same combination. That means the cluster file system or the Oracle managed file system, anything if you're using, it should be of the same combination. So you should not have a different file system altogether, right? On primary and standby. So this all are the requirements at the database end, that your database should be enterprise edition. Binary should be, you should have a sysdba privilege, you should have a control file, you should have database should be in archive log mode and non-logging mode. Okay, so these are all the requirements. Okay, the basic requirements. Now this is the architecture for DataGuard, which is bit complex. Okay, you might be feeling it bit complex, or not that much. So this is our primary database. Okay, so and this is the standby database. Fine. So there are two different uh, there are different ways to different ways where we replicate the database to the standby. So let us understand the simplest ways as of now, in which let us understand how the database works, right? We all know that all the changes are go to the redo buffer, right? This is the redo buffer, and the log writer, if you go below, log writer writing to the online redo log files, and this online redo log files transfer the data to the archive log files. Right? This is clear. This is simple. This is single. Let's not concentrate on the right portion, the standby portion. Let us consider this portion on the left portion. This is clear, right? Redo buffer to the redo log files to the archive log. Now there is a catch now over here. Now data is these changes need to be gone to the standby. So when it is writing to the archive files, there is a process where it can which is known as RFS, remote file sharing process, where which can read from the data which is written to the archive. Okay, once it is written to the archive, it reads from here and also writes to the archive files of the standby database. Okay, so this is one way for applying on the. So now there's a process which is known as the apply process. Okay, this is a process known as the apply process. It will read from the archive log files and applies to the standby databases. Okay, so this is one way of syncing the standby database. So your data is read from the archive. Okay, from this RFS process, it is writing to not only to this archive files, but on the same time it is writing to the archive of the standby as well, and then it is writing to the standby database. So this is one way. In this scenario, you need not to have the redo log files on the standby database, right? You need not to have the standby redo log files. This okay, so you need not to have the standby redo log files for the in the stand in your standby database. So you need not to have this. So this you might be thinking, the database would the standby database would have some delay in replication. Okay, if I say a transaction is committed at 10 o'clock, by the time it reaches the archive file or it is read by the archive process, then only it is going here. So it will take time, right? If it is committed at 10 o'clock, it might reach in 10:05 or 10:10 somewhere, because once it is written to the redo log files, then the process reads it and then only it start replicating. So this is one way. Second way is, if you want, your database should be very instantaneous, right? If I write over here, it should reach the standby database at the same time. Okay, that is more of known as a real-time apply. Okay, it's more of a real-time apply. So this is one way, a simpler way of doing it. No need of standby redo log files here and transmitting the data. We'll study about all these ways when we are practically implementing it. So we practically implement all the scenarios. Might we will start with this approach, then we'll move to a real-time apply. So in this real-time apply, there is a process which is known as LNS. So this LNS process is start reading the redo buffer. Now you're not reading the archive process. Now you are not interacting with the archive at the below. It is doing its task as it is. Okay. So now this is not used. RFS process is not used over here in this direction. So it is directly NSS process is reading the redo log buffer. Whatever is getting to the redo buffer, it is reading that and it's sending it over here. Okay, it is sending it over here and then it is writing to your standby redo log files and then the archive files, and then it is writing back to the your database. So at least your data is coming over here immediately. Okay, maybe it is written in some few seconds, but at least the data is coming here. So if any time your connection breaks or anything breaks over here, anything crashes over here, you have your data in your archive files or standby redo log files. Okay, so now there is no chance that in case any crash occurs on the primary, there is no chance of the data getting lost. Okay, because your standby will almost be in sync. Okay, in most of the scenarios, if you move, okay, we'll study about this sync and async mode also. In sync scenario, your standby will always be in sync with the primary. So when a log writer is writing and there's to the online redo log file, then only definitely it gets committed. At the same time, a commit occurs over in the standby redo log files as well. Okay, as soon as it writes here as well. Then only a commit occurs once it is written here. So in this above mode, it will always remain in sync. Okay, so going into this direction and going back in the apply in this as goes down and going into this direction. So definitely you might be thinking this approach is definitely better. Okay, this approach is definitely better, but this is kind of a reading in between the redo lock buffer. So might be some performance impact is there. In the Boolean approach, there is no impact as it is reading the archive process. So uh, your current things are not at all disturbed. So this is one approach is going from here, going down, which is I'm talking about, going here and then going up. Okay. And if I take a different color, not sure how I take. Second approach is growing from here and going down, then going back here. Right. So, but in this approach, the data as soon as it writes to redo log file, there is a chance that data will write at the same time on the standby redo log file. So there is a lesser chance of any loss of data if any failure occurs on the primary. Okay, so this is the basic architecture, and when we'll implement it, this would be more clarified. Okay, so let us go to the next slide. Then let's remove this. Because, okay. So log writer, we know. So log writer collects transaction redo and updates the redo online redo log files. In synchronous mode, it ships the redo information directly to the remote file server, process on the standby runs, and waits for the confirmation before proceeding. It in synchronous mode. Okay. So what happens in how does these processes helps in the DataGuard? Okay, we study how these they're different processes, how they helps in the DataGuard structure to build up is in the first approach, not always in sync. But in the second approach, there is a chance that it can be always in completely sync. So in the first approach, we have two modes, sync mode and async mode. In the sync mode, what happens is LNS process directly interacts with the redo buffer. LNS process itself is a part of a log writer. Okay, so LNS and log writer, you can consider it same. So LNS process is reading it's reading from the redo buffer, and log writer reading from the redo log buffer. Now LNS is sending to the standby redo log file. Once it is written to the standby redo log files, then only it is written to the online redo log files. That means the commit on the online redo log files and the standby redo log files will be at the same instant, same time. Okay, so now if I insert a data into this table and I see a commit, I fire a commit. So when I fire a commit, at the same time, a commit is fired on the primary and the commit is fired on the standby. So only if standby redo log file give me an acknowledgement, then only I will fire a commit on the online redo log files. Then only the commit is fulfilled or full in the sync mode. But what happens in the async mode? Happens in the async mode is data is sent at the same time, just like before, but it doesn't wait for the acknowledgement. Okay, doesn't wait for the if it is committed over here, it is committed. But async mode definitely is a performance issue. It can cause a permission issue. Why? Because commit will wait every time till the time commit is doesn't occur in the standby log files. Okay, but I think we need to pay the price for it. We have to if we want the standby should be completely in sync, always in sync. Okay, at the same instance, in production scenario, we always configure in the async mode, not in async mode. Okay, this is completely ruled out. The next option, the first option we specified, this is completely ruled out feature because this was earlier which was done. This is also one of the mechanism, but it is causing a lot of delay. Okay, which is to the standbys. Standbys would always been delay, right? And but there is a chance of standby. But in now we have sync and async mode over here, which is reading directly from the LNS. The difference between the sync and async is only this: async doesn't wait for the acknowledgement, sync waits for the acknowledgement. Okay, it can be on the same time, but there can be a gap of few seconds, not much, but few seconds. Okay, so sync waits for the acknowledgement. Once it is committed on the standby redo file, then only is committed. So once it is committed on the standby redo file, anyways it will go and apply to the standby database. Okay, and it is always in the apply mode. That means it is in the recovery mode. The standby database always remains in the recovery mode. Okay, so when you will go through, we will practically implement standby. What will happen is the database remains in the recovery mode, just like you are recovering, you are doing a backup recovery. So it remains in the recovery mode. So it generally remains in the mount stage. Okay, it remains in stage in the mount stage where it is recovering. Okay, so I think we already did this. What does the log writer is doing in the sync mode? It is in the sync mode, it is shipping the redo information to the RFS process. You can just read the second point and process and waits for the confirmation before proceeding. In the async mode, it ships the redo information directly, but does not wait before proceeding. So in the async mode, it is doing the same thing, but it doesn't wait for the acknowledgement. Okay, what is the archive is doing? Archive or the SQL is performing an archive operation, creating a copy in the primary database. It may also ship the redo stream to the RFS while simultaneously archiving the online redo log file. So one thing is definitely it will create archive redo log file just like a normal process. Second thing is it may also may also ship the redo stream to the RFS. What we discussed when we don't configure the standby or log files. Okay. So now there is a process which is known as the fetch archive log. Okay, one of the process which is known as the fetch archive log. Okay, this which is running in the FAL, which is running in the DataGuard. Okay, this is known as the DataGuard automatic gap resolution. So what happens is not in the async mode, but definitely in the not in the sync mode, but definitely in the async mode and this below mode. Sometimes what happens is it might not be able to read the archive, it might not be able to get the data which is read in the redo log buffer, so it might be left behind. Okay, due to some reasons might be left behind of the primary database. Then what does is it will automatically resolve the gap. Maybe the network is down or some or other aspect is there, automatically it will resolve the gap. So this is known as the fetch archive log process. Okay, so generally it is automatic process. You need not too much interact with this FAL process. It's an automatic process which is there in your DataGuard setup. Okay, which is automatically started internally by Oracle. This process we are talking about, this is a remote file share. It receives the redo information from the primary database. It can write the redo into standby database or directly to the archive process. Okay, so that is the remote file sharing which we have provided you here. In this the above scenario, it receives the data from the redo buffer right to the standby redo log file, and this below case reads the data from the archive process and writes to the archive redo log files. Managed recovery is the recovery process. I told you that the database, the standby database, will always remain in the recovery mode. Okay, so it is recovering whatever is, that you have studied the RMN. How does it works? You restore the database and then you recover the database. So the recovery state, what does it? Does it applies the archive files. So your archive sequences number should be same, right? From here and here. Anyways, it is a sync mode or async mode, or it is this mode which is getting the data from. It is always applying the archive files. The data is first returned to the archive files, then it is get applied, right? It is just a reverse of the primary. What happens in primary, that when you write changes to the database in the primary database, and then you write that these changes are recorded in the archive. But now in the standby, something reverse happens. First, the changes are returned to the archive, then this archive is applied on the standby, right? So something which is very reverse that start happening. So this is which is doing this is the which applying, which is recovering the data is the process which is known as MRP. You can, if you can go ahead and just check PS minus EF grep MRP, you will see this process, the archive background process, the Oracle background process MRP, which would be running on the standby database. Okay. Now, in the same way, there is a LSP process which is for the logical standby. So this structure is for physical standby. Okay. I tell you most of the times, 90% of the times, you would be using physical standby, not the logical standby. Okay, that I will tell you why we don't use logical standby much, but there are some requirements where we use logical standby as well. Okay. Okay. But the generalized case we use a physical. So in the standby, similar process which is the LSP. Now comes the standby redo log file. Okay, so this is the additional log files uh, for your standby. Don't mix it with the online redo log files. Okay, so online, once your standby redo log files are different than online redo log files. Your standby database can have both. It can have online redo log files as well as standby redo log files. So once your standby database becomes a primary database, it becomes a primary database, then this standby redo log files would not be used. Similarly, even if I make a marker, okay, similarly, this is, you can have a, you can have a what do you say, online redo log files and standby at the same time, but only one would be used. When it is in the standby mode, it will be only using standby redo log files. When it is in the primary, it would be using this online redo log files, not the standby redo log files. So standby redo log file would not be used at all. Okay, when it is moved into, when it becomes a primary database. So database can have both. Similarly, in the primary also, you can configure online redo log files and standby redo log files. Now how the standby redo log files are working, you understand, right? In this case, when we are reading the data directly from redo buffer, it is writing to the standby redo log files, then it is going to the archive files, and then over here. Okay, so this is an optional. This is optional. This is not mandatory. But when you are reading from the redo log buffer, then it becomes mandatory. If you're reading from the archive files, it becomes optional. It doesn't need it. Okay. So why we use it? Let me. I don't tell you. So standby redo log file is used only when the database in a standby role. I told you, right? To store redo data received from the primary. It forms a separate pool of log file groups. It just similarly like an online redo log file, but it is a separate pool. It is different. When you create a file, also it's a different command to use it. Okay, create standby redo log file. It's not a create log file group. It's a create standby redo log file. Configuring is highly recommended on a standby database to aid in role reversal. Okay, is required to implement maximum protection and maximum availability levels of data protection. It's used for real-time apply cascaded read log destination. Uh, Okay, so this is the I told you this feature is the real-time apply. In case of real-time apply, you need to have a standby redo log file, but in case of normal apply, you need not to have it. Okay, you need not to have it if you're reading it from the archive files, but you need not to have it. The real-time apply means you're directly reading from the redo buffer. That's a real-time apply. Okay, so we'll study about this maximum protection, maximum availability levels as well. I'm not discussing it right now. What they're saying in maximum protection, maximum availability, you need to have that are different. They are different in the real-time apply. Also, we have three categories actually: maximum availability, maximum protection, and maximum performance. Okay. So in case of real-time apply, in case of cascade redo log destination, so all these things should be used. So you understand the concept of the primary and the standby database. So primary is something which is the transaction database, and the standby database is where your database is replicated. So it is linked to one or more standby. So primary can have up to 9 standby databases. Okay, so because you can have at least 9 lol archive destination parameter, but I think in 12c it has become 20. So the limit will also increase. You can have up to 20 standby databases.
Okay, can these database be clustered also?
It can be rack as well, not a problem.
Okay, got it. Makes sense.
Yeah, right. But if the storage itself is not there, if the storage crashes, if the corruption occurred in the hard disk, then where you'll go? Rack will not, because even if all the instance, maybe if you have 4 instance rack also, no use, right? The storage itself crashes. You might need to restore and recover into a new storage. That definitely will take a long time. If it's a 9 TB, 10 TB database, you assume you will give an outage of 3 days, 4 days to the users. So you need to have a standby machine that is actually like practically implemented almost right now these days in all the production databases. Standby database. Even if you have rack or not, like DataGuard is still more implemented than rack itself as of now. And rack is not only for availability, it's also for a scalability feature. Okay, you are adding your instances. So sometimes you are scaling horizontally, and scaling up horizontally your system, maybe improvement in the performance also is seen during that. But there is nothing which is improvement for the standby perspective. It is just for the failover system. Okay, the improvement in standby is can be seen only if you use your standby as an offloading server. I told you, because standby is always in the recovery mode, right? It is always in the recovery mode, always in the recovery mode. So what happens is like it is in the mount stage, so it can be open in read only mode. So that feature is known as the active data guard. I think it is a separate license. It comes or doesn't comes to the enterprise, I'm not very sure. Okay, but it has a separate license where you can open the database in the read only mode and can still recover. By default is the mount stage. Okay, but at that time you cannot access it. But now in 12c there's a feature of active data guard where we can open your database in the read only mode. It's still recovering, and then what you can happen, you can shift all your read only users to the standby databases. Then definitely you can improve the performance as well using standby. Okay, but before 12c, if I talk about before 12c, it was used only for a failover system. With 12c only, people use it for a performance as well, additional benefit you can say. So switchover, failover, there are two things. So first of all, let's study about standby. Standby is something we already discussed. Reduce apply to the standby using standard Oracle techniques. During planned downtime, you can perform a switchover to the standby. failure occurs, you perform a failover to the standby database. The physical standbys can also use to back up the primary. It can also be used to back up the primary database. So you assume that instead of taking a backup of the primary, you can take a backup of the standby as well, because anyways it is in sync, right? It is the same database. It is in sync, so it can be used to restore or recover. So unnecessary putting burden on the primary. Let's take a backup of the standby. And switchover, what is switchover? Switchover is something which is a planned activity. Maybe you want to switch over to the standby. Switchover means now the standby becomes primary and your primary becomes standby. The roles can be reversed anytime. Okay, the roles which you see here, primary to standby. Okay, so this is configured in such a way that this now data is going from this to this. Now data can go back to this anytime. You can reverse the roles. You can reverse the roles from primary to standby to primary. So in this case, when the roles is reversed, the standbys become primary, so it is opened. Now this becomes open in the read-only mode, or in this is open in the mount stage. Okay. So anyways, one system can only be used for transactions. So when you do it, this activity is known as a switchover activity. This is switchover. Okay, switchover means no transaction is lost. You switch over. Now one is failover. Failover is automatically, or you can say failover is when actually the issue occurs and the primary is down, primary is crashed. Then you have to move to this standby. Standby becomes up. So now DataGuard has a feature that automatically it shifts it to the standby. Standby automatically opens into the, it becomes open, and it can be used. The standby gets opened. This is known as a failover. So failover is something which is out of the issue. It's not a planned outage. It's an unplanned switchover. You can say failover. And also there is a risk of losing transaction. Losing transaction in what scenarios? In this scenarios, if you're not doing a real-time apply, and in this async mode. This is a scenario where you can, there's a risk to lose the transaction. But if you have configured your database in a sync mode, then there is no loss of transaction. There is no loss in transaction. The sync mode definitely has a great benefit. So we'll configure the sync mode always in production databases, but we have to take up 2% to 3% performance over it, because the commit will only occur in the online redo log files till the time commit occurs over here. Okay, so this and this will have a same commit time. Okay,